All right, welcome back. We're going to look at the periodic table booklet you would have received, and we're going to label a few things, discuss a couple of things, and then we'll be able to get into the chemistry review. A couple of things to note, key groups to know here. This group here. All right, so this first group here is referred to as the alkali metals. Okay, this group here, alkaline earth metals. And go way over here, we have the noble gases. And this group here, I'm going to angle this piece of paper here, halogens. And another thing to note here, so this is considered to be group 1A, group 2A. We have group 3A, 4A, 5A, 6A, 7A, 8A. So that's how we refer to those groups. Those are the A groups. These here are considered to be the B groups. And another thing to mark here is the staircase, which separates metals from non-metals for the most part. So it starts here above aluminum and just runs down like this. So you can label that on your periodic table. So in this direction, we have the metals, and over in this direction, we have the non-metals. All right, so those are the key things that you need for the periodic table there to use in the class. Okay, if you flip the page over, we have this on the back, which is a very handy periodic table. It has some polyatomic ions, so groups of atoms that are joined together, and overall they either gain a negative, gain an electron, or sometimes they lose an electron and become positive, such as ammonium and hydronium. The nice thing about this chart is it tells us, especially in the B groups, we have atoms that lose more than one electron. So iron, for example, can lose 2 electrons to become positive, or lose 3 electrons to become positive 3. So again, when you lose electrons, like the metals do, you still have the same number of protons in the nucleus, so you stay positive. If you look at the non-metals here, they tend to gain electrons to become like the noble gases, and we can see that happening here. Notice that the ending changes from fluorine to fluoride, chlorine to chloride, so it adopts the IDE ending. Okay, third page, again we have everything listed there in terms of the ions. Page 4, some similar, and over here, let's put a star over here. Okay, so we'll put that there. Now, these are used when you have non-metals bonded together. Okay, we use this naming system, which indicates the number of atoms. So mono means 1, 2 means di, tri, etc., all the way through. So this is a key thing that we'll be going through, using those prefixes. If we go to the bottom here, when naming acids, we have some of the acids here that we'll be using. A couple of things that we're going to come back to, though. If we could just underline, actually, there's an R missing right here, so we'll add that R, hydrosulfuric, and put a line underneath the UR, the OR. We'll come back to that, and we'll talk a little bit about that. One of the acids that's missing from here that we should likely throw on is, it's very similar to H3PO4, except it uses the phosphite ion, so it's phos for us acid. Okay. And the next page, page 5, how we name compounds. First of all, we determine if it's ionic or covalent, so we should likely look at what's the difference here. So we can make a couple of notes here. If you look at the top, ionic compounds consist of a metal bonded to non-metal. And I'll put an S there too, because it could be a group. And over here, we'll look at covalent compounds. With covalent compounds, they consist of nonmetals bonded to nonmetals. So here we're dealing with elements on the left-hand side of the periodic table bonded to elements on the right. And here we have just right bonding with right. And we'll take a look at this when we actually get into the naming section. A couple of things to note here. Type 1 and Type 2, let's change that to Type A and Type B. So that's alluding to, are we dealing with the A groups or the B groups? So we'll leave that. We won't use this box for now because we will have access to the list of the polyatomic ions. So we won't have to know the rules there. And I think this covalent side is good. Should be good there. So if you look at the very last page, this is a really good page. It's actually an AP Chemistry Common Ions sheet. So common positive ions, which are referred to as cations, and negative ions, which are referred to as anions. Renaming the cations or positive ions, we'll use this name. So instead of using the older Q', etc., we'll use the Roman numeral system. And if we're naming negative ions, we will use the alternative name first, unless, of course, there isn't one. So if I look here, there's nothing here, so carbonate is CO3 2 negative. But when you're looking at the various types of chlorates, don't use the Roman numerals, use simply this naming system right here. All right, so that's a good start for labeling this periodic table booklet, and of course we'll come back to this and refer to this and see exactly how to use it. All right, see you again.